Have you ever noticed how solid everything feels? The floor doesn't wobble. Your body doesn't fall apart. Atoms don't suddenly stop working halfway through your day. It all feels normal, reliable, safe. But here's the terrifying truth. Everything you see only works because the universe is balanced incredibly close to falling apart. We're not living in a universe that's locked into stability. We're living in one that's constantly holding itself together, moment by moment, by following a very specific set of rules. Rules that could have been different. Rules that don't have much room for error. So the real question isn't whether the universe could collapse, it's how it's managing not to. To see how fragile things really are, we need to start small. Much smaller than planets or stars. We need to start with matter itself. Take an atom. Atoms feel basic, like the simplest building blocks of reality. But if you look closely, they're actually a mess of forces that should not cooperate. At the center of every atom is a nucleus packed with protons. Protons all have the same electric charge, which means they naturally repel each other. By everyday logic, that nucleus should explode instantly. It doesn't. Why? Because another force is stepping in to stop it. A force so strong it overpowers that repulsion, but only at tiny distances. This is called the strong nuclear force, and without it, atoms wouldn't exist beyond hydrogen. No carbon, no oxygen, no complex matter at all. Now look at the electrons. Electrons are negatively charged and should be attracted straight into the nucleus. If they did, atoms would collapse. Matter would shrink down into something unrecognizable. Everything would be crushed into itself. But that doesn't happen either. Instead, electrons spread out into structured layers around the nucleus. They keep their distance, they behave. Not because they're polite, but because the universe forces them to. One of the most important rules here is called the Pauli exclusion principle. The name sounds intimidating, but the idea is simple. No two electrons are allowed to be in the exact same state at the same time. That's it. That one rule is the reason matter has structure. It's why atoms take up space. It's why solids feel solid. It's why you can sit in a chair instead of falling straight through it. When you press your hand against a wall, the electrons in your hand are refusing to overlap with the electrons in the wall. They push back hard. Without this rule, matter wouldn't stack. It wouldn't hold shape. Everything would collapse into a dense, featureless blob. So already at the smallest level, reality is hanging together because of very specific rules doing very specific jobs. Zoom out a little and the same pattern keeps repeating. Everything that happens in the universe comes down to 4 fundamental forces. Just 4. No more, no less. Gravity, electromagnetism, the strong nuclear force, the weak nuclear force. That's it. Every star, every planet, every chemical reaction, every thought in your brain traces back to these 4. And here's where things get weird. These forces don't pull equally. They don't share power evenly. They're wildly unbalanced. And that imbalance is exactly why the universe works. Take gravity. Gravity is the force that pulls matter together. It shapes planets. It forms stars. It keeps galaxies from flying apart. But compared to the other forces, gravity is unbelievably weak. Electromagnetism is so much stronger that a small magnet can lift a paperclip against the entire pull of the Earth. That should tell you something. If gravity was stronger, stars would burn too fast. They'd collapse quickly or explode early. There wouldn't be enough time for planets to form, let alone life. If gravity were weaker, matter wouldn't clump at all. No stars, no galaxies, just thin gas spread out forever. So gravity has to be weak, not kind of weak, precisely weak. Now look at electromagnetism. This force controls electricity, magnetism, and chemistry. It's the reason atoms bind together. It's the reason molecules exist. It's the reason your body holds itself together. If electromagnetism was stronger, electrons would cling too tightly to atoms. Chemistry would lock up. Complex molecules couldn't form, and if it were weaker, atoms wouldn't hold onto electrons properly. Matter would fall apart. Once again, the universe is walking a tightrope. The strong nuclear force is next. This force glues protons together inside atomic nuclei. Without it, atomic cores would tear themselves apart instantly. But if it were even slightly stronger, nuclear reactions would run too easily. Stars would burn through their fuel far too fast. Element formation would change completely. Then there's the weak nuclear force. This one doesn't get much attention, but it's essential. The weak force allows certain particles to change identity. inside stars. It's what makes nuclear fusion possible. Without it, stars wouldn't shine the way they do. The sun wouldn't produce steady light and heat. Life on Earth wouldn't stand a chance. Each force pushes in a different direction. Some pull things together, some push them apart, some transform matter itself. If any one of them dominated, the universe would collapse or freeze into simplicity. Instead, they balance, and that balance is controlled by numbers called fundamental constants. These constants are baked into reality. They aren't settings we can adjust, they're just there. Numbers like the speed of light, the strength of gravity, and the charge of the electron. What's unsettling is how narrow their allowed ranges are. Change some of these numbers by even a tiny amount, and things break. Not slowly, completely. One famous example is the fine structure constant. This number controls how strongly light interacts with matter. It affects how electrons bind to atoms. If this number were slightly higher, electrons would stick too tightly to nuclei. Chemistry would fail. If it were slightly lower, atoms wouldn't hold together. No molecules, no complex matter, no life. And these constants don't drift, they don't wobble. As far as we can tell, they've been the same for billions of years across the entire universe. That's the only reason reality feels predictable. But predictable doesn't mean static. Creation and destruction are always happening together. Look at a star. A star exists because gravity is trying to crush it inward while nuclear fusion pushes outward. Gravity wants collapse, fusion wants explosion. The star survives in between. As long as those forces balance, the star shines. When the balance breaks, the star changes. Smaller stars fade quietly. Massive stars explode in supernovas, scattering heavy elements across space. Those explosions look violent, but they're also generous. The carbon in your body was made inside stars that died long before Earth existed. The iron in your blood came from collapsed stellar cores. Destruction feeds creation. This balance happens everywhere, inside atoms and inside cells and inside ecosystems. Nothing is fixed forever, but nothing falls apart instantly either. Life exists in that narrow window. Zoom all the way out and the pattern holds. The universe expands, but not too fast. Matter clumps, but not too much. Forces compete, but none win completely. So are we living on the edge of a cosmic collapse? In one sense, yes. If the universe's rules were even slightly different, nothing complex would exist. No stars, no chemistry, no time for life to emerge. But the same rules that make collapse possible are also what make change possible. They allow stars to form and die. They allow planets to evolve. They allow life to adapt instead of freeze. Pure stability wouldn't give us this world. Pure chaos wouldn't either. We exist because reality sits between the two. Once you see this, everyday things feel different. Solid ground isn't guaranteed, breath isn't guaranteed. Thought, memory, love, all of it rests on invisible rules holding steady. The universe didn't have to be this way. And yet it is. So maybe the real question isn't whether we're living on the edge of collapse, and maybe it's this. Why does the universe balance itself just well enough for something like us to exist at all? Comment your thoughts below, and don't forget to like and subscribe while you're there.